The amazing brain. The brain. What weighs only 2% of your total body weight but uses more than 20% of your energy? Answer. Your most complicated body part, the brain. Your brain needs plenty of energy to fuel about 86 billion neurons. These brain cells carry the electrical signals needed for thoughts, memories, and feelings. They are the reason you can ride a bike and remember your teacher's name. Neurons form a network with more than 125 trillion connections. Each connection is called a synapse. Your brain contains more synapses than there are stars in 1,500 Milky Way galaxies. This complex wiring system enables your brain to act as the control center for your entire body. 3 brain in 1. Neurons connect the brain to the rest of the body, delivering instructions to muscle and bringing back information from your senses. They also connect the 3 main parts of the brain: the brainstem, cerebellum, and cerebrum. Each brain part controls specific body activities, and they have numerous connections so that each part can communicate with the others. Brainstem. The brainstem is sometimes called the lizard brain because it's the breast much the same thing in lizards as in you. Conscious body processes that are essential for survival. Day and night, your brainstem keeps your breathing, digestion, heartbeat, and other autonomic body processes running smoothly. The lizard brain is also conscious of fight, flight, or freeze, respond your immediate reaction to difficult situation. Cerebellum. Each time you move your body, your cerebellum is at work coordinating muscle movements. It acts targeting instructions when other parts of your brain send signals using information such as your body current speed and position, with the cerebellum's guidance. You can touch your nose in one smooth motion. Without it, the movement would be jerky, or you might even miss your nose completely. The cerebellum also regulates balance and motor control and stores memories of muscle movement called procedural memory or the unconscious memory of how to do something. Muscle memories become stronger with repetition, which is why practice helps some movements, like playing guitar or skateboarding, become automatic. Some experts believe those muscle memories also reinforce pathways in the brain and make the onset of diseases such as Alzheimer's and other forms of dementia, slower or less instructive in daily life. Physical exercise strengthens more than just your body muscle, it strengthens your brain. Cerebrum. The cerebrum is the largest part of the brain. It is almost 75% of the brain's volume and almost 85% of its weight. This is where most high-level brain activity takes place, including thought, speech, learning, and emotions. The cerebrum also interprets information from the sensory information reaches the brain as electrical signals, which the cerebrum interprets as sounds, images, and other sensations. It compares the result with your stored memories and attaches meaning to each one. A stream of electrical impulse becomes a purple buzz or a crowing rooster. You may be surprised to learn that ignoring things is an important part of the cerebrum's job. To understand why, take a moment to notice everything your senses are communicating to you. Your senses constantly flood the brain with information. By screening out some things, the cerebrum helps you focus on what remains, like an adjustable filter that allows only certain things to pass through it at certain times. right brain, left brain. If you could look inside your head, you will see that the cerebrum is divided into two halves called hemispheres. A bundle of nerves called the corpus callosum connects the hemisphere and carries message between them, which allows the two halves to work together. Your hemisphere control opposite sides of your body. Your left hemisphere sends the signal to raise your right hand. Your right brain is in control when you shake your left foot. Although some tasks can be done by either hemisphere, the two are not identical. The right brain usually controls creativity, artistic skills, and interpreting what you see. The left brain generally controls speech, writing, and math skills. The corpus callosum allows the left brain to tell the right brain what you saw so that the right brain can decide what the vision meant. Without the corpus callosum, you could see the purple bus, but you couldn't tell anyone what it was. Each brain hemisphere has four sections or lobes: the frontal lobe, the parietal lobe, the occipital lobe, and the temporal lobe. Each lobe processes specific information or has a special job. However, scientists didn't release this until the 18,000s when doctors recorded the strange story of Phineas Gage. Studying the brain, Phineas Gage was a foreman for the Rutland and Burlington Railroad who were injured in 1848. Iron rode straight through his head. Amazingly, Gage survived. The hole in his head didn't affect his memory or his ability to think, but it drastically attacked his personality. Gage became rude, toothless, and stubborn, so different from his old state personality that his friends said he was no longer Gage. Gage had lost a portion of his frontal lobe, a part of the cerebrum that governs emotion and attention. His injury gave scientists one of the first clues that specific brain regions control specific brain function. It also indicated that you would damage one part of the brain and the rest would keep working, but it wasn't a complete answer to all their questions about how the brain works. Brain mapping. Doctors studied Gage's case for many years, but they did not preserve his brain when he died. Then, in 1914, when World War I began, large numbers of soldiers suffered brain injuries, and the injuries to certain brain regions consistently caused the same. With his information, doctors were able to begin creating maps of brain regions and their function. Trying to learn about the brain by studying brain injuries was more like trying to learn about cars by studying broken engines. Scientists could identify essential brain regions, but not what each region did or how the different regions work together. The ability to map brain structure is very different from the ability to map brain function. Seeing a brain activity. For a clearer understanding of brain function, scientists needed a way to study healthy brains without damaging them. In the 1920s, a German scientist named Hans Berg created a machine that could measure the electrical activity in the brain. This machine, called electron machine, provides a partial solution. Everything you do, running, singing, ticking, and more, begins with tiny electrical signals in your brain. An EEG measures these signals through electrodes placed on the head surface so that researchers can see brain activity when you walk, talk, read, and more. The brain wave rims that an EEG measure is called a Bird wave after the scientist's inventor. Unless electrodes are surgically implanted inside a person's skull, though an EEG can detect only those signals near the brain's surface. Observing activity deeper in the brain was difficult and potentially dangerous until a test called fMRI became available in the 1900s, unlike an EEG, which measures electrical activity. An fMRI identifies and maps active brain regions by measuring blood flow. This technique, which is non-invasive, which is indirect measurement of brain activity, become electrically active neurons require more oxygen. Since blood is your body oxygen delivery system, brain areas which more blood flows generally have more electrically active neurons, and unlike electrical signals, change in blood flow can be non-universally detected deep inside the brain. An fMRI allows scientists to detect the precise brain region used when you sing, laugh, or startle with far more detail than an EEG can provide. Mind control. The ability to detect brain signals raises another question. Is it possible to decode these signals? If a computer could decipher a brain's electrical signals, people might learn to control an artificial lamp or a robot through a brain-computer interface. If this sounds like science fiction thing again, experimental mind control devices already exist. Electrodes detect the brain signal, which is decoded by a computer, and the information can be used to control a mechanical device. Researchers hope this technology can be used to help people with disability move and communicate more easily. This technique could also be used to send brain signals from one person to another. In early experiments, one person's brain signal for finger movement traveled over the internet to another room. There, a special device delivered the signal to a second person. His finger moved, following instruction from another brain. This type of human brain-to-brain communication was first done at the University of Washington in 2013, just 3 weeks after a Harvard Medical School team used a different computer-brain interface to link up with a rat's brain in an experiment in which scientists used its brain to move the rat tail. Maintain your brain. Your brain is an amazing machine, and like a machine, it operates best with proper care. How do you keep your brain in top condition? For starters, easy. Exercising your brain's habits grow in the same way that muscle grow with physical exercise. Take violin players. They learn complicated finger movement from the left hand, and the brain area controlling that hand is larger than in most people who haven't practiced those finger movements. Don't play a violin, try puzzle and games you're not good at. It's a weird, but you are already good at particular game or activity, your brain wants to create new neural connection. If you are a language person, try number or logic puzzle like Sudoku. If you are good with numbers, try learning to draw. Hands are especially difficult to get just right. These activities will keep your brain healthy and strong. Also remember to feed your brain what it needs to keep working for you. Blueberries and walnuts have lots of right nutrition to keep your brain working smoothly. Brain training. Brain change usually occur only in regions directly involved with your activity. However, research suggests that some mental training may cause broader changes. For instance, research at Harvard Medical School show that people who practice meditation for 8 weeks had changes in brain regions used for learning, memory, and emotional control. Physical exercise, especially exercise that raises your heart rate, also has brain-wide benefits. Dr. Arthur Kramer is the director of the Beckham Institute for Advanced Science and Technology at the University of Illinois, where he studies how exercise affects the brain. Exercising is good for your body and your brain. Kramer says researchers show that children who regularly exercise have better memories and attention and often do better on school tests. Dancing is good for your brain because learning new steps and patterns encourage the brain to form new neural connection. It also calms the brain stress response, which reduces pain and lowers tension in your body. Sleep is another the key to maintaining healthy brain function, according to Dr. Ken Poller, director of the Cognitive Neuroscience Program at Northwestern University. Evidence suggests that your brain replays memories during sleep that may have skills and information stick in your memory. However it works, it's clear that getting too little sleep decreases your ability to learn and think. Experts recommend better between 7 and 9 hours every night. Protect your brain. According to the research of Dr. Anne M. Lee, brain protection is the most important key to brain health. Shock absorbing fluid called cerebrospinal fluid and enhanced skull guard your brain against some injuries. If you let on constrict, a fall from only 2 or 3 feet can crack your skull or burst your brain. This kind of injury, called concussion, can come from a hard hit to your head or being violently shaken. Although most concussions from playing sports are mild, each one causes damage to your brain. With rest and time, most mild concussions help completely. More serious concussion can all cause swelling inside the skull, which can cut off the brain's blood supply quickly, and your brain can survive only a few minutes without oxygen. Wearing a properly fit helmet while playing sport provides extra protection that may save your brain and your life. Your brain may be the most important part of your body. Exercise, eat brain foods, get enough sleep, and wear protective headgear to help your brain operate smoothly for years to